In this video, you will learn about Cohen's Kappa, a performance metric for a classification model. We'll show what it measures, how it compares to overall accuracy, and how it can sometimes mislead you. Let's get started. Take a look at this example workflow that predicts the creditworthiness of credit customers with the decision tree algorithm. The scorer node reports the performance of the classification model in its interactive view. In this overall accuracy statistic table, we find overall accuracy, overall error, Cohen's Kappa, and other metrics. But why do we need both overall accuracy and Cohen's Kappa? When the target class is highly unbalanced, the overall accuracy is biased. For example, when customers with a good credit rating represent 90% of the data and customers with a bad rating only make up the remaining 10%, a classification model that predicts the rating of all customers as good can reach an overall accuracy as high as 90%. Cohen's Kappa tries to correct this bias by taking into account the a priori distribution of the target classes. Cohen's Kappa is calculated as the difference between the overall accuracy of the model, P0, and the overall accuracy that could have been achieved by a random guess, PE, divided by the maximum value of this difference as given by the perfect model with an overall accuracy of 100%. To calculate the overall accuracy of a random guess, PE, you make the strong assumption that the model predictions are not affected by the a priori distribution of the target class. Notice though, this assumption is often violated when working with unbalanced data, since the classification model tends to predict the majority class in case of uncertainty. You can calculate Cohen's Kappa based on the confusion matrix. We have pre-calculated the row and column totals in the confusion matrix. In the top row total value, you see a priori probability of the class bad, 10% in our case. In the left column total value, you see how many customers of the model predicted the credit rating bad, 6%. Multiplying these probabilities, you see that the actual and the predicted classes are both bad, with less than 1% by chance. In the bottom row total value, you see the a priori probability of the class good, 90% in our case. In the right column total value, you see the predicted probability of the class good, 94%. Multiplying these probabilities, you can see an almost 85% probability of correctly predicting the class good by random guess. To get the probability of a correct prediction by chance to any class, PE, you sum up these two probabilities. Using this result and the overall accuracy value, you calculate Cohen's Kappa and get 0.279, the same as in the accuracy statistics that we checked before. Now let's go back to our example workflow. This time, in this part of the workflow branch, you can try to improve the performance of the decision tree model by resampling the training data. The Cohen's Kappa value is higher for this model, 0.380, than it was for the first model, 0.279. However, the model's performance as indicated by the overall accuracy didn't change at all. Cohen's Kappa is recommended to evaluate the performance of a classification model when the target classes are unbalanced. Cohen's Kappa has a universal range from -1 to 1, where 1 corresponds to a perfect model. However, be careful when comparing the values of Cohen's Kappa between models, because Cohen's Kappa tends to be higher when the target classes are balanced. Cohen's Kappa is also not informative about the expected prediction accuracy like overall accuracy is. The interpretation of Cohen's Kappa values, even in terms like moderate, is neither easy nor fixed. In this video, you have been introduced to Cohen's Kappa statistics to evaluate the performance of a classification model. Cohen's Kappa is a more objective description of the model's performance than overall accuracy, since it takes into account the a priori distribution of the target classes.